Here we have z is equal to sine of 4x plus 3y. I'm going to ask you to find delta, the partial derivatives, delta z by delta x, delta square z by delta x squared, delta z by delta y, delta square z by delta y squared, as well as delta square z by delta x delta y and delta square z by delta y delta x. And these two should be equal. Alright? Alright, so pause the video, write down the question and do all of them. Okay, you finished? Remember, I want you to finish all of them before you come back and watch the rest of the video, you know. Alright? So, let's see something here. A. We want delta z by delta x. What do we get for it? Well, we're going to look at using the chain rule, right? But just in case you don't remember about the chain rule, you should be able to do it by now if you've been practicing, to do it mentally without actually writing down substitution and so on. But let's do that for now. In this case, you say let u be equal to 4x plus 3y. Alright? What you have is sine 4x plus 3y. Let u be equal to sine 4x plus 3y. So therefore, z is therefore equal to the sine of u. You see that? Now, delta z by delta x would be equal to, if you differentiate this one, you will get delta u by delta x times, and you differentiate this, and you get delta z by the delta u by delta x, delta z by delta u. So you have sine 4x. Z is equal to sine 4x plus 3y. U is equal to this, so Z is sine u. So delta Z by delta u, you get that. And then delta u by delta x. Now, let me check again, just make sure. Z is equal to sine of 4x plus 3y. U is 4x plus 3y, so Z is equal to sine u. Alright. So therefore, delta Z by delta x is equal to delta Z by delta u times delta u by delta x. And then, yeah, this would cancel. These would cancel. You could also have it as delta Z by delta x is equal to delta Z by delta u times delta u by delta x. Same thing. Delta u would cancel. So in both cases, you notice what happened. Delta Z, let me use over in this case. Delta Z over delta x. Give you delta Z over delta x. And here delta Z over delta x. Because the delta u's cancel. You see that? But anyway, you would need to find out what is delta u by delta x and delta Z by delta u. So let's do that. Delta u by delta x would be 4. You see that? When you differentiate this with respect to x, What about this? Delta z by delta u would be what? When you differentiate sign, you get cos. It will be cos u. So when you substitute them into this, what you would get is delta z by delta x is equal to delta z by delta u, which is cos u times delta u by delta x, is 4. So it's 4 cos u. Now, the answer here would be 4 cos u. But remember, you didn't have any u in it. You are the one who went ahead and put it, well, I am the one who went ahead and put in the u. What was u again? U was 4x plus 3y. Alright. The only letters were 4x plus 3 and was x and y. So we have 4x plus 3y. So this is delta z by delta x. Nice. Alright. Now if you're doing it mentally, you would say the outside function is sine of something. When you differentiate sine of something, you get cos of that thing. So it's cos 4x plus 3y. See that? Times the inside function now. You have 4x plus 3y differentiated with respect to x. What do you get? You get 4. And you multiply them. So you could have got that by doing it mentally, right? What about delta squared z by delta x squared? What would that? Part B. Delta squared z by delta x squared means you're going to differentiate with respect to x. So you won't bother to use the thing there again, the substitution workout. We just do it mentally now. So the outside function is 4 cos of the function. When you differentiate that, you have 4. When you differentiate cos, you get negative sign. So it's negative 4 sine 4x plus 3y times, differentiate the inside function now with respect to x, you get 4. So the answer is multiply them, you get negative 16 sine 4x plus 3y. See that? Alright. C, delta z by delta y. Alright, so C, you want delta z by delta y. That is equal to, same kind of working. You differentiate the sign of a function, the sign of something, you get the cos of that thing. So it's cos 4x plus 3y. So this is cos 4x plus 3y times, and then you differentiate the inside function and multiply by that. And we differentiate with respect to y. We're differentiating with respect to y, right? Yeah, right. When you differentiate with respect to y, you get 3. So it's 3 times all of this. And then part D now, so del square z by del y squared. We differentiate this again with respect to y. So we differentiate cos of something, you get negative sine of it. So it's negative sine of 4x plus 3y, and this 3 is there, minus 3 sine 4x plus 3y. And you multiply that by, when you differentiate the inside function with respect to y, you get 3. So what you get is negative, well, 3 is 9, negative 9 sine 4x plus 3y. Alright? Was that what you got? Alright, so let's do the next part. We want to find delta square z by delta x delta y. So we want delta, this would be what? E. That's E. Delta square z by delta x delta y, which means delta of by delta x of delta z by delta y, which means delta by delta x of, what was delta z by delta y again? Delta z by delta y. Oh, yeah. It's 3 cos 4x plus 3y. So it's 3 cos 4x plus 3y. We want to differentiate this with respect to x. So here, using the chain rule mentally again, we have 3 cos of something. When you find the cos of something and differentiate that, you get negative sine of that thing. So this is negative, well, the 3 is there, 3 sine of 4x plus 3y, and then multiply by the derivative of the inside function. Remember, differentiating with respect to y. So when you differentiate the 4x plus 3y with respect to y, we get 3. So 3 is negative 9 sine 4x plus 3y. So that's what you got. Now, here, that was E. And then for F now, we're going to find delta square z by delta y of delta x, which means delta by delta y of delta z by delta x, right? Which means delta by delta y of, what was delta z by delta x again? Delta z by delta x. 4 cos 4x plus 3y. So we have 4 cos 4x plus 3y. So we want this with respect to y. Now, we have the cos of a function. The outside function is 4 cos something. When you differentiate the cos of something, you get the negative sine of that something. So it's negative sine of 4x plus 3y. And remember the 4. Let me fix it up. Let's put the 4 right there. Alright, negative 4 sine 4x plus 3y. And then you will find the derivative of the inside function and multiply it. Now, the derivative of 4x plus 3y with respect to y is 3. So you multiply by 3. So this now becomes 3 by negative 4 is negative 12 sine 4x plus 3y. So here, this was 4. Where we got this from now? We had, did we make a mistake here? Let me see something. When we find del z by delta z by delta x, we got 4 cos 4x plus 3y times delta z by delta x. 4 cos, this is multiplied by 4, yeah? So it is cos 4x plus 3y. Nice. Good. What about delta z by delta y? It should be 3 cos 4x plus 3y. So delta z by delta y is 3 cos 4x plus 3y. Okay, no problem. When you differentiate this now with respect to y, 4 cos 4x plus 3y with respect to y. So 4 cos 4x plus 3y with respect to y. Oh my. Guess what? Delta z by delta x is 4, not 3. Mistake. Mistake. It should be 4 cos 4x plus 3y. And then when you do it mentally, this would be 4 sine. When we differentiate this now with respect to x using the chain rule, right? The derivative of the outside function is 4 cos. When you differentiate cos, you get minus sine. Yeah, negative sine, negative 4 sine of that thing, times, then you differentiate with respect to x, right? No, with respect to y, I mean. You differentiate with respect to y. So it's 3 times 4 sine 4x plus 3y. So, my mistake there. 3 times 4 is 12 sine 4x plus 3y. Alright. So that was my mistake there. And then, of course, delta z by delta x is 4 cos 4x plus 3y. So we have 4 cos 4x plus 3y. Alright. So it's 4 cos 4x plus 3y. And when we do it, this one now, we differentiate it with respect to x. Here. Oh, with respect to y, I mean. Differentiating with respect to y. Right? This was y, and then we differentiate with respect to x. This is x, then we differentiate with respect to y. We have 4 cos something. We differentiate that. We get negative 4 sine of that thing. Multiply by the derivative of the inside function. You differentiate with respect to y, you get 3. So it's 3 fourths. So it's negative 12 sine 4x plus 3y. So you see, you get the same thing here in both cases. Alright, so that's it for now. I will see you in the next video.